Experience an evening of innovation to engage with a new generation of yacht owners. Revolutionize the industry as we know it and place yourself at the leading edge of the trend curve. This is VriThink's Night Out. This is your future.
Imagine you are going to travel to Mars, rocket, shoot off, and you're off to holidays. But when you arrive, how do you make yourself a little habitat? One way is to print it from Martian grains of sand. And in order to do that, you can't bring building materials. My name's Teun de Vries. Yeah. People from abroad call me Teun. Other people call me Tuna the fish. But as odd as my name might be, as extraordinary are my projects. And that's how I ended up in this project. What I do is I focus on composites. I focus on makeability. Anything I bring people with a great design. They come to me and say, okay, how do I realize this? And I lead them through the process of structural designers, the builders, the choices of materials, all the way through to product number one. So about 4 years back, I was stubborn enough to start my own business and started to call around, plant some seeds, and pretty soon pulled off one of my first jobs and got a call from Holspaas. And they really had some very odd thing to build and deliver. Holspaas is a company in Breskens. They produce masts for sailing boats, carbon fiber masts. And this, however, was something odd. This was something completely different, out of their league. And I had the honor to jump into the project and together realize this as it was. On arrival, they showed me this old construction drawing. I didn't have the foggiest idea what it was. It has some pill-shaped egg, which was split in the middle. It had a beam underneath. And I didn't realize it was an elevator. But it wasn't just an elevator. It was Einstein's elevator. Einstein one day witnessed an old painter falling off the roof. And at that moment, the relativity theory was born. Not very fortunate for the painter, but a big step in science. So when Einstein developed this, imagine this big tower. Inside there's a cell. When it's accelerated very quickly to 70 kilometers an hour, the actual printer inside starts floating inside the vacuum. And when it comes back, it had 4 seconds of weightlessness on Earth. So the High-Tech Institute in Hanover ordered this capsule for their tower at the Gravitational Research Institute. Aluminium would have been far too heavy, so it had to be of super lightweight carbon fiber. And inside, the deepest vacuum you can ever imagine with the modern technique available. As you can see, this is you got the upper dome of the elevator, the upper gondola, as we called it. There was the lower gondola as a half sphere, and you got the drive beam underneath. All this together, so it's basically pretty simple construction. 3 main parts. If you look at the beam, with its 3 meters in length, you could load about 5 or 6 big fat cars on top of the middle of it, and it wasn't allowed to bend just more than just a few millimeters, all due to the accuracy required in this project. The lower dome was fitted with all the technology, had all the instrument boxes, but also payload catchers. You can imagine this 3D printer inside this capsule. When it's floating inside, in weightlessness, its way down is affected by the rotation of the Earth. So something had to catch it when it comes down. Then you've got the upper lid. It actually looks like a black U-boat shape bell jar, which closes the entire lid. So 3D printer goes in, lid goes on top, vacuum's being pulled. that's when it's ready to go up into the tower, because the tower on the outside looks a bit ugly, but on the inside it's actually two steel, like a yellow and a blue tower, completely braided through one another, but each on their own foundation to reduce vibration effects. One is there for guiding it up, the other one is there for the guidance. The other one, now, how do you actually get it to be so light? There was only 550 kilos was the maximum weight limit of the beam and the gondola. And they had to shoot up 1.5 tons of loads. The only way to do this is to use aerospace composites to get super lightweights. Here we've tested the vacuum inside. When we were ready, first time we got the vacuum on, there were some big-ass pumps there which could pull the atmospheric pressure to the absolute minimum on the inside. If this would have imploded right there, right now, then our eardrums would have been teared to pieces. Accuracy on the project was amazing. It was crazy. We had to get every part built from carbon fiber and even milled back to the exact tolerance. We had items which 2 meters apart, which were 0.02. And these guys, if I would have taken one wrong step on a distance of 100 kilometers, structural designs were used to produce all the, and to determine all the loads on this structure and to find out what it was going to happen during its operational life. And of course, some hardcore builders from the people from Haasbouw were required to put the entire thing together and find every single layer of carbon fiber was handcrafted and cut to pieces, assembled, and the most extraordinary ways in order to build it were there. But only a few months back, I got a message in my app that the first parabolic flight of this tower has succeeded. All scientists have been waiting to put their tests inside. Tests we will never understand, but one day will bring us to Mars. Thank you very much.